So, up until now, we've been talking a lot about trig functions and verifying them and reducing them, like simplifying them a bit, right? Using the trig identities. And today, we're moving into 5.3, where we are solving trig functions or trig equations, really, right? Solving trig equations really isn't that different than solving any other kind of algebraic equation. For the most part, you've got something that you're trying to solve for. And the processes are all the same. It's just you have a lot more verbiage in there, right? There's a lot more words are going on when we're looking at trig functions that often kind of throw you guys off. And so I'm just going to do some examples. I've only written down 3 examples, so it's not going to be a super long class, but we're going to kind of thoroughly talk our way through each of these examples so you can see what's going on. And if you have any struggles while you're actually working on the homework, you can kind of work your way back through the video. Our first example is if we're asked to solve sine of x plus radical 2 equals negative sine of x. If you remember correctly, like normally when we're solving for something in particular, the idea is to get that one thing that we're solving for on one side of the equation all by itself, right? So that we can kind of solve for that. More often than not, we're talking about x. But what we're really thinking about in terms of a trig equation is we would want to know what sine of x equals in this case, right? And so we're going to use that same theory. We're going to try and get all of the sine of x over to one side of the equation and then move everything else over to the other side of the equation and then just simplify it as best we can. So the first thing I'm going to do is I'm going to take this minus sine of x and I'm just going to add it to both sides. When I do that, here I wind up with 2 sine of x plus radical 2 equals 0. And now we're going to start working off that sine of x, right? We're going to start taking off everything that's being done to it a little at a time, just like we would if we were solving an equation for x in algebra. Right? So the first thing I would do is I'm going to do whatever's being added or subtracted from it. So we've got this plus radical 2. I'm just going to subtract radical 2 from both sides. And I would be left with 2 sine of x equals negative radical 2. And the only thing left being done to that sine of x that's keeping us from knowing what sine of x equals is we have that 2 multiplied to it. So we're just going to divide both sides by 2. And we wind up with sine of x equals negative radical 2 over 2. That is a complete solution, right? And we didn't do anything we haven't done before in solving equations. The only difference is now we have sine of x in there instead of just solving for x. But the process is the same, right? We're going to get everything that we're solving for on one side, move everything else to the other side, and then just wean it down till there's nothing else on it. We wind up with just that equals something. Does that make a little bit of sense? I know it was a fairly simple problem. I have another sample one in there, but it's just sine of x minus radical 2 equals minus sine of x, which is basically the same problem. I don't see any reason for us to work that one out. In our next example, we're going to be dealing with squares, like when we're talking about squared functions, same thing's going to happen. We're going to deal with it the same way we would a square function if we were just in algebra, the stuff that we were doing at the beginning of this semester, right? So if I have an example that says solve 3 tangent squared of x minus 1, that 1 did not show up, equals 0. We're going to start the same thing. We're going to try and get that tangent x or tangent squared x all by itself. So we're going to start by undoing everything that's currently being done to it. And in this case, the first thing being done to it is we have 1 being subtracted from it. So we're just going to add 1 to each side. And we wind up with 3 times tangent squared x equals 1. The next thing we have being done to it is we have this 3 that's being multiplied to it. Notice when I read it to you, I say 3 times tangent squared x so that you understand that that is multiplication that's happening there. So we're just going to divide. If we're multiplying to get rid of it to the other side, we just divide. And we should divide by 3, not 2, because that's what's being multiplied. And we wind up with tangent squared x equals 1/3. And all that looks good, but it's not our solution. Why is it not our solution? Exactly, right? We have a square there. We want to know what tangent of x is, not what tangent squared of x is. And so when we want to find out what actual tangent is, we're going to have to take the square root of both sides. And so when I take the square root of tangent squared of x and the square root of 1/3, I wind up here, I'm going to have just tangent of x. And here I have the square root of 1/3. It's plus or minus the square root of 1/3, right? Because it could be positive or negative. The square root of 1 is just 1, but the square root of 3 doesn't work out that pretty. And I can't leave it in this form. This is our solution, but it's not in the proper form because we have that radical in the denominator. I know when we were doing the trig functions, WebAssign allowed us to have the square root in the denominator. I don't know if it'll allow it with these types of problems, but all we have to do, if that's the case, is rationalize the denominator, right? Whatever our radical is in the denominator, we just multiply times radical 3 over radical 3. And then radical 3 times 1 is going to be that plus or minus radical 3. Radical 3 times radical 3 is just 3. And this would be the proper solution. Will WebAssign take the first one? I don't know. They shouldn't have when we were doing the other verifying of finding all the trig functions, but it was taking it. So there's always a chance. But if not, if it won't do it, just rationalize the denominator and get the actual proper form of the solution. So ultimately, all of these solutions that we're doing are the same types of solutions we've always done, right? Isolate, right? Get everything we're solving for on one side, and then start pulling everything off of it so that it's isolated. And that'll give us our solution. And simplify where necessary. I only have one more example for us today. And this one's a little different because you have to really look at the problem and potentially factor for the solution. Well, in this one, I know we're going to be factoring for the solution, but you kind of have to look for the commonalities when we're dealing with things that might need to be factored. So if I get a problem that says solve cotangent of x times cosine squared of x equals 2 times cotangent of x. I have two different things going on here. I have cotangents and I have cosines, right? Move them all to one side. I'm going to move this cotangent of x. If I have something going on like this, set everything equal to 0. Move everything to one side so it's equal to 0. So minus 2 cotangent x minus 2 cotangent x. Sorry, put the x in before it's time. Right? And all it does is move everything over, right? So that we have it all on one side. So I'm going to go, I cannot combine these cotangents of x right now because this one is multiplied to the cosine. So this becomes cotangent of x times cosine of x minus 2 cotangent of x equals 0. I can't combine the cotangent of x to the negative 2 minus 2 cotangent of x because one is being multiplied, one is being subtracted. One, that cotangent of x being multiplied to that cosine squared of x makes them not like terms. It's like adding an x to an xy. Does that make sense what I'm saying? Like if I have xy equals negative x and I move this x over, I add x here, right? I can't go x, I can't add this x to that x. So it would be x plus xy because they're not like terms. Yes, thank you. Cosine is squared. So I just want to make sure you understand why we can't combine those. But what we can do is we can look at this and we can go, okay, well, each of these have a cotangent, right? We have a cotangent here and we have a cotangent here. So we can factor that cotangent x out of each piece. So if I take cotangent x out of this piece, I'm just left with cosine squared of x, right? Minus, well, I factor out the cotangent of x here and all I'm left with is that 2. And all of this equals 0. When we look at a problem like this and they're set equal to 0, that means each piece equaling 0 would give us a, just like when we were doing quadratics, right? Each piece, if we set each piece equal to 0, we would have a valid solution, right? Because as long as one of the something being multiplied is 0, the whole answer is 0, and it's true. And we're saying, well, what makes this equal to 0? But if this cotangent of x was 0, and I multiplied to this, the whole thing is 0. If what we have inside here is equal to 0, and we multiplied it to cotangent of x, the whole thing would equal 0. Because anytime we multiply anything by 0, it becomes 0. So what it does is it allows us to set it up so that each factor set equal to 0 would make it true. So we could go cotangent of x equals 0, or we could go cosine squared of x minus 2 equals 0. And both of these would make it true. Now the cotangent of x is already one of the solutions, saying if we make cotangent of x equal to 0, the whole thing is 0. There's nothing to do on it. But the second part, we have a little work to do because, I have to isolate this cosine squared of x before I can know what the actual solution is to make the whole thing equal to 0, right? And the way we do that is we would add 2 to both sides, and then we have cosine squared of x equals 2. And then as Moises pointed out earlier, with the tangent problem that we were doing, we would have to take the square root of each side. And we would wind up with cosine of x equals plus or minus radical 2. And what it means is that if I plugged in radical 2 for cosine of x, our solution would be 0, right? Doesn't matter, plus or minus. The cosine isn't squared anymore once we take the square root of both sides. So in the solution, it's not squared. Oh, sorry, Moises, that was from a previous. I see what you did there. I see what I did there. That question was from the previous one where I'd forgotten to square it. I thought you were asking about it in the solution now. So our two solutions would be cotangent of x equals 0, because we could not simplify that anymore. And then the simplified one of cosine of x equals plus or minus radical 2. So you're going to have to play with these types of problems a little bit. You're going to have to, sometimes it helps me to take the trig function out of it and substitute in an x mentally, because they solve exactly the same way. But sometimes seeing the sine or the cosine or the cotangent throws you off a little bit in the solution. But ultimately, we're solving these problems the exact same way. Now, I've limited it to these kinds of problems for today's. We'll do some harder ones later this week. We'll do some quadratics and some multiple angle equations. But for today, we're going to keep it simple. I'm not going to throw too many problems into the web assignment. That'll be pretty much the whole thing for today. Does anyone have any questions regarding what we just did here? No? Well, give the problems a try. I will have tutoring open today. Last period as usual, like 2:10. I don't know that I'll have it available tomorrow. I'm on the fence as to whether or not I'll be here tomorrow. It depends on how my person's appointment goes today. So if they need me, then I'm going to take tomorrow off and I won't have tutoring. But I will definitely be back by Wednesday, and I can always try and make some time that day for you guys. So let me know. Think about this. After today, only 2 more lessons. That's it. And we're done for the year. That's pretty crazy. So you guys go.